Okay, yeah, thanks for coming, everyone. So today we have a lot to cover. So let me just jump into the topic directly. First, I need to say that overall, the goal of the satellite system is to have a complete solution for behavioral control. And then for a complete system, then we have the program burned into the hardware, which controls which does the real-time control of the behavior. But we, as experimenters, we need to interface with the task control, and then that will naturally require a graphical user interface or simply an app. Or I should say, more importantly, we need to save the data. So the data has to be somehow get into the computer and saved and then pre-processed for later analysis. Last time was the first part, is about the hardware and the program we write into those hardware, and today is the second part, which is the GUI, which handles both our interaction with the system as well as data logging and processing. Yeah, so the first part for today is about the Satellites Viewer. Satellites Viewer is a graphical user interface written in MATLAB. And so to find, first, of course, to find the code, we go to the All Corner Lab GitHub, and here we see, again, the Satellites repository. We click in there. We're going to get into the Satellites Viewer folder. And this is all the code that supports this graphical user interface. Okay, so of course, I have already cloned the repo locally. Now I'm gonna demonstrate how can we install this package into MATLAB. So there are two ways to do it. One that many of you MATLAB users are familiar with, another is more specific to this kind of app, to this kind of MATLAB apps. So I'll go with the latter one first, which is actually the easier one. So I have already opened MATLAB and navigated to this folder I just showed you on the website. This Satellites repo, Satellites Viewer folder. And over here, we see a subfolder called release. Here I can click the plus sign and see the installer in there. So it has a very complicated suffix. This .mlappinstall. Basically, it means a MATLAB app installer. So this is a special format in MATLAB. If you click on it, double click on it, and we see this installation process. And here you can simply click install, and then this package will be installed. But since I have already had it, I will just click cancel here. And then to run this application, and we just simply type into the name, Satellites Viewer. Make sure it's plural, satellites. By the end of today's workshop, you will know why it's plural rather than singular. So we can simply type in here and then hit enter, just like how you run a typical function. So if it's run for the first time on your computer, that may take a little bit longer than how it appeared here. So I'll just close it, and then to show you the traditional way of adding these code, or basically in general, any MATLAB, any third-party external MATLAB code, including our custom function to MATLAB. So home, and here set path. I'm sure many of you already know, but it's just to make sure everybody is on the same page. So, and here we can click either add folder or add with the subfolders, and then navigate to Satellites repo, and then Satellites Viewer, and we can just select this folder. But obviously, I have already added it, so it doesn't show up here. But if it's not, then that folder will show up here. And remember to click save rather than directly close it. Yeah. This time, rather than directly typing into the same thing, I will show you. So I will just point out, in MATLAB, you can here favorite, or in older MATLAB versions, it's called shortcuts. You can create favorite or shortcut, new favorite, and then you can just write the command here, and then check those boxes to put it out, enlarge this. Yeah, it will appear at the top. So this is a very commonly used thing along with some other quick commands. Yeah, we can just click this. And this is equivalent as typing the same command over here. All right. This is just my habit of putting this down there. So for now, I think we can actually minimize this main window and focus on the graphical user interface. Okay, so before we jump into this like seemingly complicated interface, although it's actually not that complicated, but just to make it even simpler to understand, I would love to go to our familiar Arduino IDE, integrated development environment, and just to draw some analogies between the two. And I hope this will be much easier for us to understand. Yes, SatellitesBlinkData. So this is the second example we used last time. And basically what it did is not super different from the Hello World example of like Arduino tutorials, like just blinking an LED, except here we do two extra things. So first is that whenever the LED blinks, it will send messages to the computer, say LED on at a certain time point and LED off at a certain time point. This is the first thing it does. And the second thing it does is that we can type in many different commands and followed by various number of parameters to change the behavior of the blinking LED, like the duration that the LED is turned on, the duration is turned off, or on and off durations set at the same time, or we just ask the LED to stop blinking for 5 seconds. So last time, what I sort of skipped, or I probably didn't mention, is the way we kind of set up the hardware, and this is the reason I didn't like bring this is because I just keep using the same hardware again and again, and the Arduino IDE actually remembered my last selection. But here, if you freshly install the Arduino, then you have to go to Tools, and first is the port. You know, Arduino communicates with computer via serial ports. And of course, you can plug a lot of Arduino boards to one computer at the same time. And then you will have many serial port, or at a computer side is called COM port. And COM port 1, 2, 3, 4, 5, and on and on and on. And then some COM port may not be about Arduinos or TNZs, maybe some other peripheries like a printer or some stylus or things like that. So you have to know like which COM port your TNZ needs. And here, the COM port is COM number 3, right? So I'm explaining this is for later. We're going to draw parallels to the satellites viewer. Yeah, so this is the first thing. And once we have selected that, and let's also just upload the data, we'll upload the program into the TNZ. It's compiling sketch. Yeah, I can show you again that the LED is blinking now. And as we demonstrated last time, Arduino has a function called serial monitor. Here you see like serial monitor, and we click it, and we can see that the TNZ is continuously sending messages to us, and those messages are being displayed over here. And of course, we can, to send a command, set on duration. I would say like let the LED to be turned on for 2 seconds each time. And you can see two things. So first is this log is only about the incoming messages, right? So we typed on your 2000, but that line doesn't appear anywhere here, right? So all the outgoing commands are not logged. And so this is the feedback, LED on duration, some time, well, at certain point for some duration. This is the feedback we actually programmed into the Arduino. It's not about like or outgoing command directly. Okay, so far it seems super simple, right? And if you think this is super simple, then you will find like the Satellites viewer is as simple and as intuitive as these. So the concept I'm showing here is actually very important. But now I'm going to close it and now turn to Satellites viewer. By the way, when we click the serial monitor, like the serial port is being occupied by the Arduino IDE. So if this port is being occupied, then no other programs can connect to the board anymore. So, and the way to disconnect the serial communication is simply to close this serial monitor. So you don't have to close the Arduino IDE. I will just minimize it for now. Okay, now let's turn to this little graphical user interface. So we opened the app and we didn't do anything. You actually cannot do much before adding a channel. So I will explain later what a channel, like why we have a concept of channel here. But right now, let's just add a new channel. Although you see a window popping out, and it seems a lot more options and more complicated than the Arduino IDE. But here I just want to highlight some very simple settings that directly link to what we are talking about. So once you open it, you are in the general tab, but let's go to, well, in the general tab, like we are in the standalone mode. I will explain what these modes are later, but standalone mode is a mode that's completely equivalent to the situation we were in the Arduino IDE. But let's go to the serial tab. And here we see the familiar serial port selection, right? We know like this TNZ board we are working with is COM3. And here you can additionally set the baud rate. Well, not additionally, Arduino IDE also allows you to set the baud rate. But this is just the rate we typically use. And yeah, so we set the COM3, and let's just give it a name. Let's call it TNZ demo, or simply call it demo. And then save configuration. The configuration is saved successfully. And we see now a line here, right, named demo, and it's connected to port 3. And right now, we don't have any incoming and outgoing messages. But you may say like, wait a moment, but aren't you right now like connecting the TNZ to the computer, and whereas the TNZ is running, you see the LED blinking. So then you're supposed to see those continuously generated incoming messages. Well, we don't see that because this channel is not enabled. So when you, meaning like the port is actually, the connection to COM3 is not established yet. So, but now we can enable this channel, and you see the logs, number of logs is increasing. But we can show the log window, and here we see a pop-out window. And isn't this window basically the same as the serial monitor in Arduino? And in fact, it is almost exactly the same. And we can just pull it to be longer. So on the top, this slot is where you can, just like the Arduino IDE, you can type in commands. And here, let me just show you the first difference. If I'm say, well, let's change to again to 2 seconds, because we previously unplugged and replugged this, so the program in the TNZ restarted, and then all the parameters went to the default ones. So let's just say the on duration 2000, and when I click it, you see that I mean it's changing. So let me just temporarily disable this channel, so it stops updating. So it's easier for us to look at. You see, like our outgoing messages is actually being logged. So this is different from the Arduino serial monitor. And the way to tell the difference between incoming messages and outgoing messages are by the symbols before them. So you see, like, this is the leftward arrow means the incoming messages, and the rightward arrow means outgoing messages. So here's the second important difference between the two. So in Arduino serial monitor, what you see is what you have. So for example, in Cohen Lab, like they use either the original Arduino IDE serial monitor or something very similar, just logging all the incoming messages. And at the end of each session, they basically like right click on their interface and say like, or Control A to select all the text, and Control C copy them and paste it in a text file, right? So basically the data they get is what they see in the log. But here it's different. In the log window, this is just the message being displayed. And you can actually configure both how things are displayed as well as how things are logged. So let me explain it in more detail. Again, a lot of settings and loggings can be found in Configure window. And here we go to the last tab, logging. This is a complicated tab, but here is something, a tool that's very useful to quickly visualize what's going on. Okay, let's see, for example, like if we received or send, if we send or receive a message, hello planet, and this is a message we basically, you can imagine, like we just type in here. And we can control what is the actual message being logged. So the first question is, why do we want the two things to be different? Well, we want it to be different because we may want to add some additional markers to it, or we want to add additional information to the message to enrich the messages. And here's, let me just uncheck everything. So if the message is this, and with the current selections, and the logged message is the same. But what we can do is, well, okay, so first of all, sorry. So here is a checkbox, and which allows you to decide whether we want to log those output messages or not. If it's unchecked, then the behavior is exactly the same as the Arduino IDE serial monitor. And here we checked it, then both incoming and outgoing will be logged. And here we can add an input or output tag. So here you see, like when I check or uncheck, you see it's a I, comma, capital I, capital I, comma in front of it. And if we say aloud, this raw message is actually an output message, and then it says like O, comma, hello planet. So why do we need this? It's basically this for the same reason as if we don't have those arrow markers in front of it, it's very hard, unless like we are the programmers, it's very hard to tell like what messages are incoming and what are outgoing. And similarly, when we actually log the message, the arrows were not there. And so here we can select the add input output tag to put a tag in front of it. On the other hand, we can add additional information to it. So this is a system time tag. So why system time tag? Well, so you see, like if it's LED off, and I'm just randomly hitting some machine time to it, but the machine time is precise, right? It's real time. It has real time millisecond precision, but it's kind of meaningless to the real world, right? So then we also want to know like what is the time in the real world. And then if you add a system time tag, then it is 2020, October 15th, and 13 hours, 58 minutes and 48 seconds and 198 milliseconds. So this is the time that my computer, my desktop, processed this incoming message. And by default, all the 3 checkboxes are checked, and then the tag delimiter is comma. So I remember last time I just asked, but she was asking about the Arduino library part, like in the satellites library, can we use a different delimiter to separate different parts of a message instead of a comma? And I say yes. So, but for that you need to like change a property in the object of satellites in the satellites object. And but here you can also change the delimiter. I said using the $sign, and you can see from the simulator, like the input output tag O and the system time and the actual message is now separated by the $sign. Of course, it doesn't replace anything within the message, and that is determined by the Arduino satellites library, right? But I found no reason to change it to any other symbols, so I would just use comma. But you can certainly use other symbols. All right, so and we actually didn't change anything, but I'll just save configuration. Now let's say like we want to save the data, right? And so to save the data, we can simply click here, save log, and it will ask us like where to save the log, and I'll just find a random place. And you see the default name for this log is SatellitesViewer log, year, month, day, and the time. And but you can also use this. Oh, and if we don't want to add the time, we can uncheck the append time. And now when we save again, you see it just a SatellitesViewer log. And we can also provide a default file name as mouse001. That could be a good name. And we want to append the time for this mouse. And if this is a behavior data, and we save log, you see now we see mouse01 and date and time.txt. And I will actually save these just to be clear, to make it absolutely clear. What do I mean by what we see here is not necessarily what we get, right? So this is what we see, and this is what we get. And we have additional system time in front of the actual message, as well as the input output tag in front of the message, all separated by commas. Just to show you, this is the O here, which is this line corresponds to that line. So right now we have 93 lines, and we can actually, well, if you no longer need these, or you want to like start something from fresh, then you can empty log. But here it's prompting, it's warning, because this is going to be permanent. If you click yes, delete all, then there's no way you can retrieve it. But I will just go ahead with it. Okay, so that's everything about the basic communications. Now we are going to move on to the next section, which is about sending commands. So right now I will enable this channel, and we see data being generated again, and then we can again control it. Let's say off duration half a second. Yeah, and it's being changed to half a second. But we know like there are a few commands we can use, and then like it's really cumbersome if we have to like type in every command every time, right? So it would be nice if we have some ways to store those commands, or even better, to generate some graphical user interface, so we can directly just like click and change the numbers and type. And of course, it would be nice if none of these requires any programming. And this is what we are going to cover. The first is called quick commands, and the second is called command groups. The idea for quick command is simple. So quick commands is the second tab of this GUI, and then we see a lot of text boxes there, and all of these text boxes are equivalent. You can just pick where you want to write, and you can just write it. I'll just pick here, and I say like on duration to 50 milliseconds, and off duration to 50 milliseconds. And I can create another set of like on duration, let's say like 500 milliseconds, and similarly off duration 500 milliseconds. And if you remember, we also have the on off duration and followed by two numbers. This applies 1,000 milliseconds or 1 second to the LED on time and 2 seconds for off, all in one command. And let me just like clear the log so we can see what's going on. So if I click the on duration 50 and off duration 50, it's being generated much faster because the messages are generated every 50 milliseconds of time. And we can click these two in quick succession if you need. And then now it's goes back to half a second. And then we can click here once. And you see the rate of message being generated are a lot slower, and which follows the durations we specified. So this is quick command. So then what do we do with quick commands? So for example, like you want to test some new parameters, or some sets of new parameters, and then you can just write them there, and then click on it when you see fit, and you can see how the animal behaves and so forth, and like change to something else. And then those are like really quick to edit and apply. And then, or in other cases where you want to, for example, provide some water with certain amount, or you want to just test the system using some testing function you wrote in there, or you're trying to debug something, then that's all where you can use quick command. Yeah, just to summarize, what it does is basically just send this into Arduino as if you are just typing the same message here and hit enter. Okay, so now I'm gonna show you something that's really, really powerful, which is the command groups. To really efficiently to interact with the ongoing behavior, graphical user interface is the best, right? But for many other behavioral control systems, for example, the B control system or BPOT and others, so you have to get into, in that case, the MATLAB code, and then like to build your GUI programmatically, often in a procedural way. And this is kind of difficult and time consuming and annoying. And oftentimes we don't really need that level of flexibility or complexity to achieve something that are actually really simple. And for complicated things, and later we'll go to user functions and we'll talk about that. But the idea here is like we can generate a GUI by simply editing some Excel file. So then later this Excel file will be processed by the Satellites viewer and being transformed into a set of GUI controls. So this spreadsheet will have 3 columns. So the first is command name, or you don't have to call it command name. I'm just writing it out for you guys to see. And the second is value, and the third is some label or a note. Here I'm just calling it parameter name. So, and for this little program, this SatellitesBlinkData, and we know what commands they are, right? So on duration, off duration. And so here we have to provide a value. Otherwise, the satellite viewer will think this is a command without any value. So we have to provide a default value here. So I would just use the same value that's default in the Arduino code. LED off duration. And then the third is on-off duration. Okay, but how do we deal with this? We know that on-off duration is a command with two values, but here we only have one column. And the way to do it is basically follow the on-off duration, follow this command name by two rows, right? The first row being storing the first value, and the second row storing the second value. And for the for the label, and I can simply just copy what's above. I actually forgot what the other parameters, but let me just check. I think there's just one left, right? Yeah, pause 5 seconds. Pause 5 seconds, and then couldn't be more straightforward. I'll just say pause 5 seconds, or we just don't give it any label, which is fine. And so, you know, like pause 5 seconds is just a command. It's a bare bone command without any parameters followed. And here we can just leave it empty. All right, I'll well, instead of sheet 1, I will give it a more informative name. Blink params. And I'll just save it somewhere. I'll just put it in a download. Demo command groups. All right, back to Satellites Viewer. And here we can see like there's a button called Load Command Groups, and we click it, and we navigate to the folder where we saved the Excel file, and double click it. And you see it finds, oh, there's a one tab in it, and we select it and click OK. Little GUI is being generated, and with some text edits and some buttons. Well, actually, you see here, well, okay, so you see here like this, the button here labels the command name and is followed by the value, and here is the label, right? And this is the second command, and this is the third command, which has two parameters in it, and then this is the last one without any parameters followed. So actually, here I regret not putting a label on it because the button has certain width, so it's the text being cut off. So let's just, I just added it and saved it, and then let's just load it again. All right. Yeah, you see it's changed. That's basically how easy we can create such a command group graphical user interface. And then let me just empty the log and then enable the channel just to play with them a little bit. And you see this is the, I think 1 second on, maybe 1 second on, 2 seconds off version. And we can say on duration 1, off duration 1. And now it's like 1 second on or off, and on off 500. It's getting faster, and pause 5 seconds. It's pausing for 5 seconds. And of course here, and we can change to 600 and then 80 or any values you want to change it to. But here's the important thing. Whatever change you make here is not gonna change in the Excel file. And then, well, and you can also see like there's no like save button for the command groups, right? So this is a one-way one-way trip, like only from the spreadsheet to the GUI, but not from the GUI back to the spreadsheet. So what I didn't mention is this button, right? So this all button is applying all commands above. So this is not a very useful button in our case, because like, let me just first show like what happens when we click this. I click all, and see there's a burst of ongoing command being logged, right? So on duration, you can see the arrows on duration off. Let me just disable it for now, for a moment. So on duration, off duration, on off duration, those are all our word commands. And as well, and immediately we get some replies, right? So LED on being changed to this and that, and also like pause 5 seconds and being paused for 5 seconds. So this is not a very useful thing, because it doesn't make sense to change like all these parameters like immediately. But you know, when we before we start a behavioral session, we want to apply a lot of parameters that will be used during the behavior, but doesn't actually drive any actions. So that the all button will be very handy in that situation. So you can apply a bunch of like dozens of parameters all at once. Sometimes we want to use 80 and 500, and some other time we want to use like a longer set of durations. So then how can we instead of just editing them back and forth, so can we just store them in a way that's just convenient to use? And the answer is yes. Of course, you can always just create additional Excel files, but you can also just create more tabs to it, right? So here we are adding another tab. Well, actually, in this case, I will just copy I'll duplicate it. Move to the end and create a copy. Yeah, so we have a blink parameter 2. And we can call like this is blink parameter 1. And here we can change it to like half of the value in the first page. And we save, close it, and open commands group and finding the same file. And now we are looking at like 2 entries here, because there are 2 tabs. So we can actually load either one of them, or we can select all, both, or Control A, and then OK. And now you see like we have 2 tabs, and the 2 tabs work independently. Yeah, so that is a command group. Yeah, so next topic is about remote. I will see if I can do it in 10 minutes. Again, a lot of things about the channel can be found in the configure window. We configure it. So far, we have been talking like all about like the standalone mode. But the reason like the satellite system is called satellite is its ability to network with multiple devices and really build a network just like a satellite. Like information can be relayed from one device or one computer to another. So far we can control this. We can control the satellites. We can control the TNZ from this computer. But what if we want to control the TNZ from a remote computer? For example, like I'm using the computer in the office, in my desktop in the office, but what if I want to control the same TNZ in front of me, but from the rig room using the rig computer? So in that case, you can imagine the rig computer will send a command via the internet, and specifically through a protocol called UDP, and to my desktop. And my desktop will act as a server to relay that information into into the Tinsy. And it also works the other way, right? Like if the rig computer is a server and my desktop is a client, and my desktop can send a command to the rig computer, and the rig computer send the command to the Tinsy at the rig. It also works in the other direction, right? So if the Tinsy is sending, okay, back to the first scenario, like my desktop is a server and my rig computer is a client. So it also works in the other direction from Tinsy to computer, right? If Tinsy is reporting some message like LED on time, LED off time, and then my computer as a server can relay that information to the client. So then the client can and the client will basically see the Tinsy as if it's directly connected to the client, although it's going through the server. So basically, I was explaining the server mode, and then let's change to the server mode. And if you go to the serial tab, nothing changes here because the server is still communicating with the Tinsy, just as in the case of standalone communication. Nothing has changed here. But what is changed is this tab, in this tab, the UDP IP. So here we can actually tell this channel like what clients are there, right? So the client is basically the information about my rig computer. So I know, so many rig PC, or you can give it any other name. And then the IP address of that computer I've already checked is this. And we will use a port. And if you are setting up a new connection in a random computer, you can simply use the default value like 8009. But I know for a fact that my rig computer has this 8009 occupied, so I will on both my desktop. They don't have to be the same, but I'm just like picking the same number so that here I'm using 808 to send out the information from my desktop, and over there I use the 808 or 807 or whatever to receive the information. So here I can save configuration, save correctly, and I will try to enable it, and it enables. And sometimes when you set up the UDP thing and you enable it, it says something is not successful, the channel cannot be enabled. And one possibility is that the port is being occupied. Then you have to just sort it out. For now, I will stop sharing the screen and then go to my rig and to see how we can set up the rig computer to actually receive the messages we are streaming to. Yeah, so I don't have Zoom on this computer, so I hope this is fine. Okay, so I have fired up MATLAB, and here I have a shortcut. I'll click Satellites Viewer. All right, so this is an empty one. So I'll add a new channel. So you see, this time we will set up the channel as a client because this is not directly connected to the Tinsy we're playing with. That one is in front of my Office desktop. And so this is a client. Yeah, so basically what I did is I added a new channel. I clicked here, and then and this is the window after I clicking that. And then by default it's in standalone mode, and now we change it to client mode. And I'll just demo client. Yeah, just let me know whenever the camera is drifting away. Yeah, demo client. And you see, if we go to serial here, everything is grayed out, right? Because client doesn't connect to any hardware directly. It only connects to the internet. And here, the only thing you can set is the server IP, right? And if you remember, our server IP is this, I'm not sure. I think it's 227. Yeah. And we set the port to be 808. It saved it successfully. And then let's show the log window. Yeah, and then enable. Yeah, you see the messages coming out right here. So then where is this message from? Then let's go back to our server. Yeah, so the flow of data again is from Tinsy through this USB to my computer, and which is displayed here. And at the same time, my computer is sending that information through the Ethernet and to here, to this computer. And here, I'm going to show you the other way around, right? I am saying, I'm typing the command on duration 50 and to in here, and I hit enter. And you already see this line here. I'll temporarily disable it so we can see the messages clearly. And this is the outgoing command. And here we actually get the feedback, right? And so this outgoing command goes from this computer through the Ethernet to the desktop, which is the server, and the desktop relays this message to Tinsy. And then Tinsy, after receiving this message, will report this feedback. This is just how we program it in the code, and then send it to the desktop computer, and desktop computer relay it through the Ethernet back to the client. Okay, welcome back.
Hey, can I ask a quick question?
Yeah.
So when you're setting the port number, are those numbers arbitrary, or is there some?
Those numbers are half arbitrary, half not. And okay, let me explain. So there are ranges of ports that are like designated for things. Like for example, if you browse, if you use internet browser and the browser uses some port number by default, and so you cannot take those. But those are all very kind of lower end port numbers, like a few dozen, like within 100 or 200. And here we are using like up to 1,000, so which is fine. So you can check it out. You can just Google it, like what is the safe range of ports to use. But here, like the ports around 8,000 is fine, and you can specify the port number up to like 60,000. Last part of the remote is like, why do we need to set up remote? And there are two reasons. So first is obviously it's convenient, right? Like you guys remember when we were working in Rangos, the rig and my DAX is pretty far away, and it takes a few minutes to walk back and not a few minutes, but take a while to walk back and forth. So setting up this allows you to monitor the animal remotely. And the second, I think, is actually a more important reason to have the remote is data backup, right? You see, like the data is being logged. So right now the data is being logged both on my desktop here as well as in the remote computer. So if one computer has some like software crashing or unexpected things, or Windows just for some reason like updated to start updating your computer, then you have the other one with the intact data, and before you actually save it, because the data is not secured before you save it, right? And so during the behavior sessions, then you have actually two copies of data. For example, like just a few days ago, I was doing experiment there, and at the end of the session, I just habitually like emptied the log before saving it. I just say something there And it just brainlessly just went to this button, I emptied log, and I clicked yes, I want to empty it. And then I immediately realized, oh, I haven't saved the data yet. But fortunately, I have the exact same copy over here. So I can just save it from the client side, and I got the same data. But this is not always guaranteed, especially when your log is super, super long, because the UDP connection sometimes, very occasionally, may lost data. So then there are many advantages for UDP connections. That's why I chose it. And in addition, the B control system also uses UDP connection to transmit data between between the real-time Linux to the computer. So the problem, in theory, can also happen there. Yeah.
And one other clarification thing. So if you send a command from the client, the system timestamp is kind of the time the server sends the command to Arduino. Is that true? And just like for your own notes, do you make any distinction about like when you're controlling remotely or whatever? I don't know if the time difference.
Yeah, that's a very good question, and thanks for bringing this up. So let me just quickly send a command, and then can you please just help me to watch here? Is there any like rightward arrow popping out?
Yeah.
So if you send a command from the client, it will be logged both on the client and the server. But if you are sending a command from the server, the outgoing command will not be logged by the client. You know, there's a one-way flow of direct information. Okay. Yeah. So far so good. Next is a big thing. It's the user functions. So I expect to spend about 40 minutes talking about user functions. I mean, this is really elastic because user function has basically, I should say, like 90% of what I'm going to talk about user function, or 95%, is MATLAB programming, basically. If you know MATLAB programming very well, and you can basically just listen to the 5%, and then you get everything. But here, just to make sure to drive each point home and to make sure everybody is perfectly clear, and I will actually use some examples to show like what we can do with user functions and how can we put what we learned about MATLAB into this situation. What is user functions and why do we need it? So you see, like we get a lot of data coming in, right? Like LD on, LD off, and we are basically passively receiving them and doing nothing. And in the end, we just like keep the log by saving them. These are messages, and there are other messaging systems. For example, emails. You know, for people who like receiving emails for a living or processing emails for a living, and they really love some functionalities in Outlook. For example, like if they see emails from certain senders, then just automatically sort those emails into certain folders, right, for certain topics. And then they can also set up some auto reply mechanisms. Like, for example, there's some emails with some keywords, and then that will trigger the auto reply of certain information. And the idea is the same. In experiments, we want to know what's going on, right? And instead of just looking at those, it would be nice to actually visualize them. And then basically visualizing the data is in fact a response to an incoming message, right? It's just like there's an email coming in and we are making some responses. And also we may want to automatically change the parameters controlling the behavior or giving the animal some feedback. That's basically like the auto replies in email. And we will look at how we do that, how we do both using user functions. So user function obviously is a MATLAB function that we write. And then functions, in order to execute a function has to be called, right? Then the question is, when are user functions being called? So the answer is user function is called every time, every single time that a channel receives a message. So for example, here, if we see like 10 messages or 100 messages, then the user function we specified will be called 100 times. And every time the function is called, only one message is accessible. So first, I basically created a function called SuppressBlinkEvents. First, where do I save these examples? Actually, there are like 2 examples I'm going to talk about today. So those examples came with the SatellitesViewer code, and they are in the private folder. So basically, any folder with private, so the private is a special MATLAB reserved folder name, where it will be automatically included if the parent folder is included to the path. So we added the satellites, we added this to path, and then since the private is right beneath this folder, right inside this folder, so then everything in here will be automatically added. However, you don't have to put your user functions in a private folder, although you can, but you don't have to, as long as MATLAB knows, as long as the folder where you keep the user function is in path, then MATLAB will be able to find it. This is a function with 1, 2, 3, 4, if you include the end here, like 5 lines, and it has 1 input. And actually all user functions has 1 input, and which is the object here. So this is an object, but object of what? It is an object of the user function model class. You don't have to worry too much about like what exactly this user function model is doing, and as long as you know there are few important fields here. So there's a channel name where you can, the proper channel name, you can use obj.channel name to know like which channel we are dealing with, and this is given by the system. And then what is the incoming message? Like, what is the message we are handling? And what are the output messages? So you can, like, this is like the auto reply, right? You see some email, and then by some keywords, and you figure out like what the message to automatically reply to the sender. And you can put the you can put the command here for sending it out, and it's displayed. So actually it's all explained here. I'm just going through it. So it's displayed. So are we going to display the incoming message in the log window here? So a lot of times there are just a lot of frequently occurring messages that's valid data, but there's not of interest for looking at them. So then we can set the display to false, so we can just suppress the display of those messages, and which is what the first example is going to do. And later we'll go into more depth about like the user data. But first, let's come back to the SuppressBlinkEvents user function. So here is a simple if and else if structure. So if the message begins with LED on, so obj.beginWith is a method here. It's a method. The method checks if a message begins with the given string or not. Here it says, oh, whenever this function called, that means we received the message. And here we are checking if that message begins with LED on, comma, or not. And if the message does begin with LED on, comma, then we set the display to false. So then this message will be logged, but will not be displayed in the log window here. If this message doesn't begin with LED on, comma, then we can test whether it's begin with LED off, comma. If the condition is met, then we also set it to false. So it will suppress both LED on and LED off. But just to make it a little more fun, let's just like keep it super simple, right? Just like let's just still keep the on time but suppress all the LED off messages. I think that's going to be more intuitive to see later in the demo. Okay, so that's it. That's our first 3-line user function. And now let's come to the SatellitesViewer GUI. And again, we configure the channel. And here in the user function, we say suppress blink events. Suppress blink events. And we save configuration. Let's empty the log so we can see things more clearly. And now I'm going to enable this channel. And as you know, like there will be a stream of messages coming in, and I enable it. Okay, yeah. So this is great because you see two things happen. First is we still see LED off, but at the same time, the user function here, like previously it was like suppress blink event, but now it's gone. And that means an error has occurred when SatellitesViewer are trying to execute this function. And when this happens, SatellitesViewer generates error, save the error information to saves the error information to the current folder of MATLAB. So we can load it, and here we see a variable E, and we can just see what's going on here. You see, this is a MATLAB exception, and the information is an undefined function, suppress blink events. Oh, I had a typo here, right? It's a double P, SUPPRESS. Yeah, that's going to be an easy fix. Yeah, we actually don't have to disable it. We can just directly change the configuration. Suppress blink events. So this time I will be extra careful to make sure my spellings are correct. I think so. Save command. Okay, right now you see all messages we see are LED on, LED offs are being suppressed. And because the object.display is changed to false for those messages.
So
here
Manny, so the changing the object.isDisplay parameters just changes whether the message is going to be logged or not. It doesn't change whether the message is going to be sent or read, right?
So yeah, remember I said what we see here in the log window is not what we got.
Right.
So we still got the messages.
Got it.
But we're just not displaying them. Yeah, thanks for saying that. That's actually what I'm going to go to right now, which is I'm going to just disable it for now. I will just save this log, and I'll just let you see what we have. I will scroll directly to the end. Yeah, you see, unlike the log window in the app, we actually have all the on and offs here, right? So the key here is like there's no way for the user function to change data, right? So like to change the raw data, I should say. So it only affects the display.
Right.
And in behavior, the things we typically suppress is basically the lick events, right? The lick on, lick off. If we are showing all the licks, then we're not going to see any useful information anymore. So, all right. So that's our hello world example for the user function. Yeah. Now let's move on to a drastically more complicated example, which is plot detection task. But before we get into this, we will need a similarly more complicated examples. So here we are going to upload. Make sure before you upload any Arduino program, make sure you have disabled the channel. It's not going to cause any problem. It's just like if you click, it will report error if the port is being occupied. So I have disabled it, and now I'm going to upload this program. So I went through this example in details in the day one workshop, but after that, and also in order to present today's example better, I actually made some modification to this protocol, to this code. And here I just want to quickly go through the changes I made. First is I'm going to change some pin numbers to work with my demo hardware. And then, like previously in the two protocol examples, I'm based on the name, we have two protocols, right? And then the way to choose which protocol to execute was previously in the reader, right? So in the reader, if we see, there are a bunch of if else conditions to see what like command names and parameters we are at. So previously, if we see like LFW command lick for water, then we execute the lick for water protocol. And if we see the DDT command, the detection task command, we execute the detection task function. But actually a better way to achieve that, which is actually what we did in the sequence linking protocol, is that in the reader, we only change the protocol ID, which is a runtime parameter. That's a runtime global parameter. That's accessible anywhere in the code. And in the main code here, so this part, so these few lines are actually in the loop. This is the main, the first tab of the code. So we added this switch case structure, right? This, if the protocol ID is 0, then breaks directly. Nothing is executed, then the loop is being just run again. And then if the protocol ID is 1 and it goes to this case, then it executes the lick for water. And then if it's 2, then it goes to detection task. And let me see what else. And all the other changes are just some are relatively minor and corresponding to the changes about like the protocol ID structure. All right. Okay, so let's upload. And we actually don't need to have this anymore. Just close it. So here we have already had a lot of parameters, right? Like water duration, ITI duration, no lick duration, stimulus duration, response window duration. The lick for water protocol doesn't need the stimulus duration, whereas the detection protocol requires both the stimulus and response window duration. So then you can imagine how one can use Excel file to create some useful command groups for each of these tasks, and then to group these parameters together and then change in the way that's convenient. Right? Just a little recap to what we were talking about in the first part. And we can re-enable it, and then we can say PID 1, which is, let's just directly use a more interesting one, the detection task. So the structure of the detection task is there will be a stimulus with certain duration. And after the stimulus, the animal has to lick the port. If the animal detects the stimulus, the animal has to lick the port within certain response window. And if it did, then there will be a water reward immediately delivered to the animal. You see the three kinds of events, right? The stimulus, the water deliveries, and the individual licks. But without any visualization, this is what we have. So I can lick. Oh, what? Here's what I'm doing. I'm using this little thing, and then I can tap the lick port. See, trial start, and I missed because I didn't respond within the response window. Okay, anyway, so this is a task, and we sort of know what's going on by looking at the logs, but it would be nice to have some visualizations, right? Especially when the task becomes more complicated, visualization becomes important. So let's say PID 0 just to stop the task for now. Okay, now we are going to look at the second user function that I have already written for this protocol. First of all, a MATLAB thing. So we know when we want to start plotting something, and we make a figure, and then we have, let's say that we just plot a scatter plot. So we have axis, let's say it's just 10 values or 100 values, and then y. Oh, sorry, axis basically 1 to 100, let's say, and y is this, and then we plot x and y, and with using scatter plot. Yeah, so this is what we have, and then but here let's just imagine the x-axis is time, is 100 time points, and then there is a value at each time point. But in user function, this is not going to be the way to plot things, because x and y, the values in x and y are not given at the same time, right? So they are given one by one. So when the first message comes, then you have one data point, and when the second message comes, you have another data point. And here, so this is just a casual presentation, but if I have to give a homework or something, then the homework will be, so try to plot the same scatter plot I showed you, but one data point at a time. So in that case, we will have a for loop. Although here I already know like how many there are, and then so I had to plot x I, the ith element of x, and then the ith element of y, and in the scatter plot, and I will hold this on, right? Because if we don't do this, next time it cycles back, then it will erase what's been plotted before and plot again. Just to make the simulation a little bit more realistic, I will artificially pause each plot each one by 0.2 seconds. Or 0.1 second. Yeah, I will run this little code. Yeah, so this is actually what's going on using the user function. So except that, yeah, it's all done. So except that the user function is really just the 3 line, is really just equivalent to the 3 lines in there, right? The for loop is basically simulating the fact that we are receiving one message at a time. So for each message, we can extract a value here, we can extract a value here from that message, and then we just plot onto an existing axis. And we'll see a little more complications later, but this is the general idea. Okay, now let's go to the plot detection task. And here you see a big if condition. So here is that right now we don't have any figure, right? So but a data point has to go to somewhere. So here shows if the figure doesn't exist, then we're going to create the figure, and if the plotting axis doesn't exist, we're going to create the axis. And here comes the user data, right? Whether it's a figure or axis or some runtime variables. For example, we are going to have the trial number, the current trial number, and then the reference time. What do we want to be a 0 time for each trial, right? So those variables will actually persist across individual calls of user functions. So then user data is the place where we want to save those persistent variables. So we want to carry around for the next and the next and the next call of this function. And any variables you created outside of it, for example, here I'm creating like a equals 3, and then after this function is executed, a will be gone. Okay, so here, what this condition is basically saying that if the user data structure doesn't have the field called fig axis 1 t0, or the figure handle is no longer valid, and that happens when we basically close that window, right? So the window was created, but we close it, then this previously saved figure handle is no longer valid. Anyway, if any of these conditions is met, then we're gonna recreate the graphical user interface, basically the little plot we're gonna do. And the figure is basically a figure, and we can give the figure a name. And this is the standard MATLAB thing. And create an axis, and we can beautify the axis a little bit by initializing the axis limit to be from 0 to 5 seconds. And then here is the way we implement the hold on. So if you simply say hold space on semicolon, then the MATLAB doesn't know which axis to hold on, because in the callback function, it's kind of ambiguous, because these things are also technically, as well as the command group GUIs are also technically figures. If you do hold on, then it will basically just activate a random figure on. So here, and we specifically turn on the hold for axis 1, which is created here. And we label the x-axis, and here, as before, we are specifying x label to this axis and title to this axis. So here are the differences for typical MATLAB plotting. And like I said, we want to have the trial number persisting, which actually I don't think is necessary here in this example. But anyway, but this is necessary. Like, when do we want it to be the 0 time, which you'll see in a second why we need this. So every time, if every time we want to access these variables, we have to type obj.userData something, that's too cumbersome, right? And this little section is basically just like bringing them out and to create some shorthand variables, so later it's more concise to use them. But different from our first user function example, where we simply suppress certain kinds of messages, and here we actually want to plot the information out, right? So, but the message comes in the form of a text string, although the text string has numbers, but it's still a text string. And these two lines are basically the way we can parse the text string and then turn those text numbers into numbers. So first we string split, we split the incoming string using comma. And then after the split, it's gonna be a one-dimensional cell array of individual fields of that string. And basically for the second to the last element, and why second to last? Because that excludes the first command name, right? Command name is a string. It's a character string. And then for the remaining actual values, and we run the string to double, and then I'm just assigning them back to the same variable. This variable has its first being the command name string, and all the followings are basically double type numbers. And after that is just a familiar if, else, if, else, if structures. And if the message begins with lick, comma, then this is the time we're going to plot a lick, right? And you see some calculations here. This is basically converting milliseconds to seconds. And here we are plotting, you see only a single data point, right? T lick is the time of lick. And for the Y value, we simply use 0 because there's no other dimension to plot about. And then again, just want to highlight the difference. So in this, when using plot, we need to tell the plot function which axis we are going to plot into, because this is a callback function, and the callback function doesn't know, or is ambiguous. The default axis is always ambiguous in the callback function. So we need to clearly specify that. And then this is just a little beautification of the GUI. Like if where we are plotting outside of the limit, then we're going to extend the x-axis limit by another 5 seconds. And again, here, if we see that, we're not going to display it in the log window anymore, because that will clutter the other more useful messages. So here I'm basically using a variable here is display, but at the very end, I will assign this variable back to the property of obj.isDisplay. And don't forget to assigning it back, and as well as the other variables, because these variables per se doesn't persist. The only thing that persists is the object. Okay, so next I will go more quickly. So if we receive the trial, a message called trial, then we know this is the beginning of a new trial, and here are where we're doing several things. First is we clear the axis, we clear the plot, and then we reset the x limits, and we reset the reference time, right? We reset where the T0 is, and then we update the plot to reflect the current trial number. And if the stimulus is delivered, and we figure out like what is the stimulus starting time and what is the duration, which are the second and third field in the message respectively, and then plot it out using a little dash to see the x-axis, and the y are all zeros, and so forth and so on. And water delivery, similar things, almost exactly the same, except that the color, we're going to use another color for that. And you can also do something at the very end of the session, like detection task ends. But here we just do nothing. And I'm running it here just as a placeholder. Okay, a demo, that's basically it. Let's configure this channel. Well, actually, let's add a new channel. Demo 2. And then user function is called, I already forgot, it's called block detection task. Let me check the spelling. Plot detection task. Okay. Yeah. So here we can select which channel we are working on. So right now it's demo. I will enable it. Well, I will disable it and go to demo 2. But one thing we need to do is choose the right COM port. So you see, like here, they can be all about the same hardware, but their configurations are different, and we can activate either one of the two. But of course, you can add channels for other devices. For example, you can connect like 5 Arduinos onto this desktop, as well as remotely connecting to a few systems through the Ethernet, and then you can just have a pile of channels. And here I'm at demo 2, and if I click show log window, and we see a separate log window coming out, right? Well, in this case, I'm sharing the same port, but if they don't have any connection conflicts, then you can operate all devices at the same time. Channels are basically independent from each other. So this is basically why this system is called the satellite system. It's a plural satellite system. So one interface can basically control all the rigs in the lab, whether locally or remotely. And then they can collect data and do feedback controls all independently, visualizations. Yeah. Okay, back to this, and then we can enable it. And then we can start the PID2, which is the detection task protocol. I hope there's no error popping out. And you see, immediately it triggers a plot. Yeah, I kept it missing because I'm not tapping the thing. So I can lick. And you see the water. So this magenta bar is a stimulus, and then the deep dark blue bar is the water. And you see I missed the response window, so there's no water coming out. And this is just a simple demo of what the user function I just showed you did. Is there any questions? Because I think we're a little short on time, but the last part is actually very important. Okay, then I will just move on to the last part. So the last part is about pre-processing the data. So we have data saved here. Let's see which one is better to use. I think all of them is good. So here we see a function called satellite.m. So this is not part of the satellites viewer. It is the code. It is data processing code, a data analysis or pre-processing code. And here I just want to mention one method. There are many useful methods in here. Just want to dive into one, which is the import. So let's just do it. Satellites import, and let's not provide anything. If you don't provide anything, it will ask you to select a file, which, by the way, which is a log file. Let's just use the first one. Okay, so what we got is a structure, and we click into the structure, and we see the text line. So these are the 72 or 70 lines of the text, and then there's no invalid ones, and line parse. So here you see it event parse. So it's for these 69. I actually don't know why 69. Anyway, so you see, click into it, like the parse already parsed, and then timetable. Here, like we didn't tell the import function that there are many trials. So then without that information, the import function basically treated the entire thing as one episode or one trial. But you see, like, here are all the time points of trial start, and here are all the time points for stimulus being delivered, and for miss, and 45 licks, and hit times, and so forth. But we actually can tell like how to cut the data into episodes and then group them as rows in the table I just showed you. And there are many fields in there. And one of the options for this import function is called delimiter events. And then and we just say, let's use the trial as the delimiter event. And I kept the first argument empty, and that's why it's prompting me this. Okay, so let's click into this variable to see how it is right now. So you see the timetable as well as the value table has become more than one row, right? So here we are basically parsing trials. So the first row is everything that happened before the first trial occurred. And here you see from the row 2 to 8, all the trial times are now 0 because we are using trial as the delimiter to parse data. So then everything else, now the time of everything else is with respect to the delimiter times. So that's why you see all the stimulus time are also 0 because that happens immediately at the trial start. And the miss, all the misses happens at 1 second because that's the timeout of duration we set to. And those are the licks, right? See, I only licked at 4 of those trials, and those are the lick times in milliseconds, by the way. And those are the hits, and water delivery time. So timetable only includes data that that's immediately following the message name, right? So we are talking about the data sent from the TNZ to the PC, to the computer, right? And if you remember the satellites the Arduino satellites protocol, like the first is just a message name, which is followed by the machine time, and which is followed by multiple custom values you want to report to. And it could be the duration, it could be some integer categorical values and so forth. But the timetable in this structure here only include those machine times, like only associate events with machine times. And the value table are those following the machine time, the value that follows the machine time. And as you can see, the trial here is 1, 2, 3, 4, 5, 6, 7. That's because let's look at the raw data. Oh, this is not that one. This one. Yeah. Because let's just find one. Yeah, this trial. Yeah, the trial, comma, machine time, this, and comma, this is the value we provided. And the trial 1, trial 2, trial 3, and the value table stores those. And similarly, stimulus also, the messages about stimulus also reports the duration of the stimulus, which is here. And whereas you see all the miss, licks, hits, and except for water delivery are all NaN, because there's nothing followed by the machine time. So there's no value, but they are there because they are events that actually happen. So, but with placeholders. And so episode rev time are where delimiter times happens. So these are the absolute times of the delimiter events, which is the message about trials, right? The trial messages, plus a 0 at the very beginning. And then for anyone who has used M-Section Explorer, and like there are timetables and value tables, and this is where they came from, and why they are there. But here, for example, especially in this value table, the miss or leaks are really not necessary, right? Those are all nans, and you see like in the M Session Explorer, you often do not see like value table that have leaks, and that has to do with the customizing the import process. So far, you see, like to have these kind of highly pre-processed and organized data, all you need to do is this such a simple line here. And as long as you follow the Satellites Arduino protocol and then use the default parameters in the Satellites viewer, and if you don't like mess with the formatting of the commands, or you mess with it, but you keep everything consistent from the beginning to the end, then this is all you need to do to get those organized tables. But still, you can really optimize and customize it using the other functions in here, right? So the import function internally actually calls a bunch of these functions. And first of all, the import function itself actually receives several additional parameters here. So you can already configure it to a certain extent. But if you really want to like deeply configure it, like for example, if you want to only keep certain variables into the table and then removing others, or you want to create your own sort of pre-processing system by directly working with the text files or text strings or just the parse strings, then you can use the other kind of functions. And then each of them has certain level of customization. For example, here, additional variables. Yeah. That's it. So yeah, we made it in 2 hours, almost exactly. So I hope this time I'm presenting it better than last time. So a little bit more smooth, and yeah. So what do you think?